Hi class, we're going to have to do a little bit of reviewing of inverse functions. If you recall, when we first talked about inverse functions, algebraically we flipped around the y and the x value. Graphically what happened is like for example, if I took a picture like, I don't know, if I had something like this and I found the inverse of that function, then what we did was we took all of these x and y values and we switched the order of them. So essentially that graph would then be flipped over this line y equals x. So that would look something like this actually is what that would look like. Okay. Now we came to a problem where if I had a graph like maybe a parabola or something like y equals x squared, when I tried to graph that, well, okay, the inverse would look something like this, but the problem is that's not a function. It doesn't pass the vertical line test. So what we had to do is we had to put a restriction on the original function. So like if I had the graph of y equals x squared and I wanted to talk about its inverse, I had to restrict the domain of y equals x squared from negative infinity to positive infinity, and I had to restrict it from like 0 all the way to positive infinity. And then my range, remember that the domain and range for my original function to my inverse function, the domain and the range, they flopped. Okay, so the range of the original became the domain of the inverse function, and the domain of the original function became the range of the inverse function. So we're going to do the same kind of thing here, but we're going to talk about the inverse functions for sine, cosine, and tangents. So this is what I was just talking about, that the domain and the range essentially flip around. Oh, I guess that's the second bullet point here. And that if the inverses undo each other, right? The function, and I take the inverse of the function, then that undoes each other, and you just get the value of x. And the reverse of that is true. The function of the inverse function also gives you a value of x. So let's recall what is the domain and what is the range for sine. The sine's domain is going to be, well, from negative infinity all the way to positive infinity, and the range for sine also goes from negative 1 to positive 1 inclusive. So what if I want to talk about the inverse function? Well, if you think about the original sine function, the original sine function, which I have graphed here for you, it's not going to pass the horizontal line test. It's not 1-to-1. So back to this original one up here, I had to restrict this portion because it was not 1-to-1, meaning that it didn't pass the horizontal line test. So then when I flipped it over, then this, if I graphed it with that original, this wouldn't be a function because it wouldn't pass the vertical line test. So we had to put some restrictions on it to not include this portion, which meant this portion never got graphed, thus making this original one 1-to-1 pass the horizontal line test, and this inverse an actual function. It passes the vertical line test. So I've got to put some restrictions on the sine function because as of right now on this picture, it's not going to pass a horizontal line test, meaning it's not 1-to-1. So if I try to graph its inverse, it's not going to be a function. So let's think about how we can restrict this domain. So what we did was we restricted the domain to be here from, that's why I have these little lines here. I'm just kind of showing you a window. I'm gonna limit this from negative pi over 2 to positive pi over 2. Because on that little window right there, that's 1-to-1. Okay, ignore all the rest of the picture, but inside that little red box I just made, it's going to pass the horizontal line test. So let's think about this in from our unit circles perspective. So we don't want any y values to repeat, right? So that way it'll pass the horizontal line test for sine. Okay, we're talking about sine, so I'm looking at the y values. I don't want any of the y values to repeat. So no y values repeated for sine. So thinking about all the coordinates on the unit circle, well, where does all those y values repeat? Well, if I go from the first quadrant to the second quadrant, right, this y value and that y value are both at the same location, so it can't be in both quadrant 1 and quadrant 2 at the same time because those y values repeat. So looking back to here, right, we're restricting it from negative pi over 2 to positive pi over 2. Why did I choose those ones? Okay, so if I'm at 0, going up to positive pi over 2 is there, going down to negative, going in the opposite direction by pi over 2, that's where we're going to restrict our domain for the inverse sine function. So it's not going to be located all here in quadrant 2 and not located all here in quadrant 1. That from here all the way down to negative pi over 2, there's not going to be any repeating of y values, which is why the horizontal line test passes here. I can do all kinds of horizontal lines in that little window, and there's not going to be any y values that repeat. So the domain, so the domain is going to be from negative 1 to positive 1, right? So I'm just flipping around my domain and range from before. Well, actually, I'll show you in a second here. And then the range is going to be from negative pi over 2 to positive pi over 2. Recall that every time we seem to be doing sine of an angle, and it spits out a ratio of sides for us. Well, what if I go in the opposite direction? What if I do the inverse? Well, now my x and y values are switching their places, what they're representing. So to undo sine, I can take the arc sine. So what we take the arc sine of is we take the arc sine of the ratio, and every time it's going to spit out an angle. So the sine of an angle spits out a ratio. The arc sine is going to spit out its angle. So thinking about that, okay, if I think about the sine function, the domain, it was from negative infinity to positive infinity, but now I'm restricting it. I'm restricting it from negative pi over 2 to positive pi over 2. So that way none of those y values repeats. And then my inverse sine function, the range is then going to become the same thing, negative pi over 2 to positive pi over 2. So the only numbers that the inverse sine function can give you, the arc sine function can give you, is negative pi over 2 to positive pi over 2. The range for sine was from negative 1 to positive 1. And that's going to become now the domain for the inverse sine, from negative 1 to positive 1. So if you even right now try typing in your calculator arc sine of 2 or something, it won't do it. It'll give you an error. Why? Because the domain is restricted only between negative 1 to positive 1. So finding an exact values of these inverse sine functions. So find the arc sine of 1. So think about going backwards here, right? This is asking us, right? This is our ratio. It wants to know what's the angle. It's going to spit out an angle. It's asking me what angle. So here's what I'm thinking. Think. Where does sine of what angle gives us a ratio of 1? But we're restricting it only in quadrants 1 and 4. Quadrants 1 and quadrant 4. Remember we said it can only be between negative pi over 2 and positive pi over 2. So that means that we can't look here and we can't look here. We're only in the first quadrant and the fourth quadrant, between negative pi over 2 and positive pi over 2. That's the only places where the arc sine can be drawn at. So if I think about like this point, okay, where is the sine going to be the number 1 in between the first and the fourth quadrant? Well, the only place that sine is equal to 1 is up here. There's the sine value of 1. So thus, the arc sine of negative 1, or arc sine of 1, I'm sorry, positive 1, is located at the angle pi over 2. Remember, arc sine, arc cosine, arc tangent, they're all going to spit out an angle measure for you. Sine, cosine, tangent of an angle will spit out a ratio, but we're doing the inverse of that. Let's find the exact value of the arc sine of negative 1/2. Again, I'm thinking, okay, where is the sine of what angle is going to give me a ratio of negative 1/2, but only in quadrants 1 and 4. So only between negative pi over 2 and positive pi over 2. So quadrants 1 and quadrant 4 is what I'm asking. This is coming up with an angle. So in drawing this, can't be in quadrant 1, can't be in quadrant 4. It's between here and here. Where is the sine going to be equal to a negative 1/2? All students take calculus. Oh wait, cosine or sine here has to be a negative ratio. So thus I already know it can't be in the fourth quadrant. Or sorry, it's a negative. Oops, it has to be in the fourth quadrant. My bad. Okay, it can't be in the first quadrant because it would be positive in the first quadrant. So now I'm asking myself, well, what angle gives me a sine of 1/2? What's our reference angle? Oh yeah, a reference angle of where sine is 1/2 is located at pi over 6. This is where your unit circle is a major deal. So if this reference angle here is pi over 6, and I know I have to draw it in the 4th quadrant, then that must mean that this original angle must be negative pi over 6. Remember, it can only be between negative pi over 2 and positive pi over 2. Okay, so you can't go around in this other direction here. Okay, don't do that. Don't even put that on your paper. Okay, blech, erase that. Okay, it can't be in that direction because it can't go through the 2nd quadrant or 3rd quadrant. Our only options are from negative pi over 2 all the way up to positive pi over 2. So this angle, so the arc sine of negative 1/2 is then a negative pi over 6. So let's talk about the inverse cosine function. It behaves very similarly to the inverse sine function. But notice that cosine is not 1-to-1 either, meaning it doesn't pass the horizontal line test. So I've got to restrict my domain on this in order to talk about a function, an inverse function. So we're restricting the domain between 0 to pi. If I look at that little window right there, okay, that would pass the horizontal line test. So, and that's something that fits on my unit circle. So from 0 to pi is 1-to-1. That fits that'll make it so I can do the inverse of that and have it pass the vertical line test. So that means if it's only going from 0 all the way to pi are my only options, I can't go into negative pi over 2 because think about that. If I go in this region here, I can't have any y values repeating. I'm using cosine now. No y values can repeat. So thus, I can't go like I did for sine. It's going to have to be limited to the 1st and 2nd quadrant. So no x values can repeat for cosine, leaving us with just the 1st and the 2nd quadrant. So we're putting restrictions on this. We're only saying that this is going to go from the values of 0 to pi, and then the domain will be from -1 to +1. So I'm just taking so I basically took my cosine function, and I'm doing the inverse of that. So the cosine, we're restricting the domain. So domain, we're restricting it to be something that'll pass the horizontal line test, which will be from 0 to pi, also known as it being 1-to-1 to pass the horizontal line test. The range for cosine normally goes from from -1 to +1. So now for the arc cosine, also known as inverse of cosine, its domain is going to be from -1 to +1. So you can't take the domain of 5. It won't work. The range is going to be the domain of the original that we restricted, and the range will be from 0 to pi now. So let's do the same thing we did a second ago for sine. So we're thinking here, this is some kind of an angle. So I'm thinking cosine of what angle gives me 0. That's my ratio. You take the arc cosine, arc sine, arc tangent of your ratio, it spits out the angle measure. So when does that happen? But specifically, it's got to be in the 1st or in the 2nd quadrant, meaning it's between 0 and pi. So that's got to happen, all right, only in the 1st and the 2nd quadrant, between 0 and pi. It's the only place that I'm allowed to graph the arc cosine. So where is that cosine going to be equal to 0? Well, there's only one place on there where it's equal to 0, located at the point 0, 1, meaning that angle is at pi over 2. So the arc cosine of 0, 0, is pi over 2. Okay, so what cosine angle now gives me a √2/2, but I gotta only have it in the 1st and in the 2nd quadrant, only defined between 0 and pi. So where that happens, where's cosine equal to √2/2? Oh, that has a reference angle located at pi over 4. So if I have a reference angle here, pi over 4, oh wait, all students take calculus. Oh, but this is a positive √2/2. Cosine's positive in this quadrant when I only have the options of 1 and 4. So thus, there's my angle, and the angle happens at pi over 4. So this is equal to pi over 4 then. Next one here, okay? Cosine and arc cosine, they undo each other. So thus, this is just pi over 12. That's it. So you guys are going to watch the second video now to be able to determine, so for the notes on the arc tangent.